first of all, let's draw this thing. What kind of graph are we going to get with a third power? Yeah, low to high, low to yeah, something like that. So it's going to have a point of inflection. If it was just y equals x cubed, that point of inflection would occur at the origin, wouldn't it? What's the minus 2 going to do? Well, this will move in the x direction. This will move right 2. And up 1. So our turning point's not going to be at the origin. It's going to be at 2, 1. I guess if you want to plug in 1, if you plug 1 into the function, what do you get for your y value? 3/4? Okay. So 1 3/4 is going to be where this graph starts. And if you plug in 4, the right endpoint, what do you get? 4, 3. So we got that going on. It's chopped off when x is 1 and x is 4. That's all part of it. They gave us that 1 to 4 interval in the problem. Yeah, otherwise you won't really know how wide to make the region. All right, so let's figure out how wide how do we figure out how wide each rectangle is going to be?
Oh, it's BA over
Yep, b minus a, in this case is 4 minus 1. That's 3 units. Divvy that up with 5 rectangles, and that means each rectangle is going to be 3/5 of a unit wide. So we got our width taken care of. The hard part's the heights, because the heights are all different. The width's nice and consistent. So if I were going to start on the left, I'll call it, I'm going to call that area using left-hand rectangles, A sub L we'll call it. I would need 3/5 out front, because that's just my constant width for each rectangle. The x values that I'm going to use, am I going to plug in 1? Yeah. If it's a left-hand rectangle, I got to start on the left side of the region. It means I'm plugging in the very first x value that I possibly can. So I'm going to plug in f of 1. Is it f? No, it's y. Darn it. I'm going to plug in, I'm going to get y of 1. And then my next rectangle would be how many units away? Yeah, 3/5. Because the rectangle ends 3/5 of a unit later. What's that? Yeah, so the next thing you're going to plug in is 1 and 3/5. And the pattern continues, right? I'm not going to write them all. The last thing I'm going to plug in is going to be 3/5 short of my right endpoint, won't it? So 3/5 short of 4 would be what?
3 2/5.
3 2/5, yeah. I mean, that's not going to be my answer, but that's going to help me set up my answer. Because my answer, I'm supposed to use sigma notation. So I'm going to write the same thing. The 3/5 won't change. I'm going to throw in the sigma. Well, the number on the bottom and the top, they have to be like counting numbers, right?
So I equals 1
integer.
equals 4.
There's a number of ways you can look at it. Whatever I do, I want my first I want my first value here. Whatever I plug in here, I want to give me 1 for this, right? So whatever I write in here better give me a 1. I'm going to leave myself more space. And each subsequent number better give me 3/5 more. So what I'm going to do is I'm just going to say 1. And then add on to that 3/5 I. Yes, because this will change. So the first rectangle. Now, think about this. If you want to land on 1, what does your I value have to be in here? Well, you want your I to be 0, don't you? Otherwise you're doing 1 plus. Yeah, gotcha. You want I to be 0 because plugging in 0 for I will give you 1 for your x value. And that's what you want. So I'm going to plug in 0. How many rectangles am I using? 5. Okay. I'm going to plug in 0. I'm going to plug in 1. I'm going to plug in 2. I'm going to plug in 3. And I'm going to plug in 4. It's weird to say 4 and you're holding up 5 fingers. But when you're starting with 0, that's kind of what you have to do. So I'm going to stop it when I plug in 4. And you can test this. Plug in 0, you get y of 1. I want that. Plug in 4, and you get 12/5 for this, which is 2 2/5, right? Plus 1 will give you 3 2/5 for your last rectangle. Okay. That's the sigma notation shortcut for writing out the left endpoint area. Once you have that, the right endpoint is going to be pretty easy. You're still going to have 3/5 of a unit for each rectangle width. So we don't even need to change that. What's different now, though, is instead of starting when x is 1, we want to start on that first jump in. So we want to start with 1 3/5. You can even recycle this pattern. Yeah, the only difference is going to be you don't want to start right away. You don't want to start immediately on the left endpoint. You want to start 1 rectangle in. To make up for that, just change your lowest I value to 1. And what that'll do is it'll jump 1 rectangle in right off the bat. And it'll skip that left endpoint. So we don't want the left endpoint.
Don't you have to do I is 3/5?
Well, the 3/5 will get multiplied by. So I is always going to be integers.
Okay.
And it's the number in front that'll make it a fraction for you. So we want to plug in 1, 2, 3, 4, and 5. That's our 5 rectangles. So we can stop and we can plug in our 5th number to get our 5th rectangle line. And test it. Once if nothing else, make it a trial and error thing. We want our first value to be 1 3/5. If I plug in 1 for I get 1 3/5. Good. Your last number, you want to stop on the right endpoint, which is what? 4. So let's plug in 5, which gives you 15/5, which is 3. 1 plus that would be 4, and that's what you want. You want 4 to be your last x value before the problem ends. Fair enough? Let's see. That's it. We got a worksheet.